Aloha's Alge 2. Today we have section 4.5, which is quadratic equations. And the question is like, aren't we doing the same thing again? Well, before we were doing quadratic expressions. And there's a main difference between quadratic equations and quadratic expressions. And it is that word right there. And if you notice, that word right there has the word equal in it. Okay? And so that just means we're dealing with something that looks like a quadratic, but it has an equal sign. And whenever it has an equal sign, it means we have to solve it. Now, what does it mean when we have to solve it? Well, let's get to it and show ya. All right, here we go. So in able to solve these guys, we need to know this extremely important property, which is the zero product property. Some books call it the zero factor property. And what it means is this, okay? If I have two factors and I'm multiplying them to be zero, what would that mean? The only way that that could be true is if A was zero or B was zero. One of those two would 100% have to be accurate, okay? Now, taking it a step further, let's say we had A times B equals 4. Would that mean A is 4 or B is 4? No, it doesn't, because A could be 8 and B could be a half. And that would give me 4 if I multiplied those two things together. There's actually an infinite amount of possibilities you could come up with in that scenario. For example, A could be, let's say, 16, which means B would be 1/4. They both could be negative. Oh my gosh, the possibilities are endless. So why is this so important? I'll say it again. If I multiply two things and the answer is 0, it has to be the case that one or the other has to be 0. Hopefully you buy into that. It's something you will use the rest of your math careers. Let's get it. All right, now how do we apply that to a quadratic equation? Now, why is that a quadratic equation? Because it's a x squared polynomial with the highest degree of x squared, and there's an equal sign in it. Now, whenever we solve these equations by factoring, we always want to get a 0 on one side. Now, class, everybody at home, is there a 0 on one side? Yes, there is, Mr. T. All right, sweet. That means let's get it. All right, now what do we have to do to get it? Well, we look at this and we need to come up with factors, okay? Because we need two things being multiplied to use that zero factor property, okay? We need two things multiplied. Well, how do I do that? Well, Mr. T, that looks like the super duper fast way. Well, if it's a super duper fast way, we simply go boom, side work. We do the first guy times the last guy. 1 times 6 is 6. And the middle guy is -5. Well, there's a lot of ways to get 6. 6, 1, 2, 3. Not a lot, but okay. A lot of people would think a 2 and a 3 work here. 2 times 3 is 6, but 2 and a 3 gives me a +5. Okay? And what did Mr. T say? Well, if that's the case, then you just make them both negative, right? -2 times -3 is 6. And if you add them together, you get a -5. So let's get it. Remember, we can do this one the super duper fast way. What would that look like? That'd be an x there, and then a -2 and a -3. The only difference here is we have that equal 0 guy. But now, since I have two factors, I can do this little thing, schling, split it down the middle, and I'm going to set this first thing's got to be 0, or is very important. The second thing's got to be equal to 0. Let's do a little math. +2 + 2. That means x has to be 2, or x would have to be 3. And what this means is that if x is 2 and you plug it in there, you're going to get 0 as an answer. If you make x 3 and you plug a 3 in for all those x's, guess what you're going to get as an answer? 0. All right? So if x is 2 or x is 3, this guy up here is going to be equal 0. And that is how we solve a quadratic equation. I think I need some green tea. All right, here we go. What are the solutions of this quadratic equation? Now, hopefully everybody's at home is saying, hey, Mr. T, there's something different here. You said that the only way that we can do these problems is if you have a 0 on the other side. And you're right, I did. Is there any magic, cool swim moves you could do to get a 0 on one of these sides? For sure. Let's move that 12. How do I move it? Well, if it's a -12, I'm just going to add a 12 on both sides. Okay, and then I guess this sweet dude right here. And then, oh, that's a quadratic. All three terms, there's nothing in common. Oh, sweet. There's a 1 right there. Super duper fast. Let's get it. All right, 1 times 12 is 12. That's a -7. 6 and 2 won't work. 3 and 4 works because that gives me 7 when I combine them, but I need a negative. So let's put negatives there. That bad boy works. Let's get it. This is super duper fast. X minus 3 minus 4. Don't skip the steps, those smarty pants at home. Spling. So that means that this guy has to be 0 or this guy has to be 0. Solve both of those guys and you get x equals 3 or x equals 4. Now it's important to know what that means. What does it mean out there at home? If you plug a 3 in there, you get 0. If you plug a 3 in there, you get 12. If you plug a 4 in for those x's, you get 0. If you plug a 4 in there, you get -12. That is way, I don't know about you guys at home, but that is way too cool. All right, let's keep rolling. Oh, I skipped a whole bunch. Oh, that's practice makes perfect. You guys know that. Do some of that stuff. All right. Okay, now it says solve a quadratic equation by graphing. We're going to actually do this both ways, okay? Now, the first thing is we all know if we do it by hand, okay, that I need this guy here to be equal to 0. So if I do it by hand, I'm going to subtract the 15, right? And then this is going to be a good one to do because can I do it the super duper fast way? Darn it. But then, hey, I don't know about you, but I kind of like writing down a lot of work. So let's do this, all right? There's nothing common with all three of those, so we go straight to side work. 2 and a -15 is a -30. Middle guy is a 7. Well, what works there? A 10 and a 3. Oh, but I need something to be negative. Let's make that guy. -10 times 3 is -30, but if I combine them, I get a -7. So Mr. Tanaka said if it's the number, but the sign is different, we just play a little flip-flop. 10 times -3 is -30, and if I combine them, I get +7. So how do we do this guy? Well, Mr. T said we write down the first dude, we write down the last dude. Okay, instead of that, how can I get that? Well, with a plus 10x and a minus 3x, right? And then remember, this equals 0, since it's an equation, just hangs on. We got a groupity groups, minus sign in between. Very important to pay attention to. What's common with these two guys? A 2x. Take a 2x, division, right? Factoring's division. Divide that, you get x. Divide that 10x, and you get 5. That negative sign's got a carry. 3 and 15 both have a 3. -3x divided by -3 is x. And -15 divided by -5 is +5. Oh, sweet! Same exact thing in parentheses. So I've got those factors right there. And what do they have in common? They have an x plus 5. Splingy, splingy. What's left? And that goes in the other parentheses, a 2x minus 3. Whoa! Mr. T, you didn't give yourself enough time to do the spling. So let's go ahead and we'll just kind of keep it over here in blue, okay? So we have an x plus 5 equals 0. So that means x equals -5. Boom. Or, very important that you write, or, splingy splings. I have a 2x minus 3 equals 0, which means you got to add the 3, divide by the 2, and I get 3/2. So it's a fraction. No biggies. But if I plug a -5 in there, I get a 0 as an answer. If I plug a -5 in there, I get 15 as an answer. If I plug a 3/2 in here, I get 0 as an answer. If I plug a 3/2 in here, I get 15 as an answer. Well, Mr. T, that was a lot of work. What if the SAT said, hey, yo, this is in the calculator section? And if this is in the calculator section, we just go bam. Okay, bring out this bad boy. Let's plug that guy in. Now, I find it much easier if we go ahead and we plug in what we were trying to solve. So that means we needed a 0, right, class? So our equation is going to be 2x squared plus 7x minus 15. And we leave out that 0 part, okay? 2x squared. Okay, what do we have there? Plus 7x minus 15. Okay, and I'm going to keep this on my big screen here. All right, we're going to always hit zoom 6. Okay, get that standard viewing window, remember? See what happens. And guess what? We want to know when this quadratic is equal to 0. What's equal to 0 wherever it crosses the x-axis, because that is when the y would be 0. So then we use this handy dandy second calc. Okay, look at the red, right, that I'm using here. And we're going to choose the zeros because we want to know when it's 0. And then we go ahead and we take our cursor and we go to around where there is a 0. And it looks like, oh, see that it took a while because I needed that x to be close to -5. All right, and then what we do is we go to about where it is, and when it says left, we go to the left 2 times. Okay, and then we go back to where that 0 is, and then we go to the right 2 times. And if you look, they have in our sweet new 84s, they have like those little dashed lines that says the 0 are in between those two things. And then we hit enter. So there we go, -5. And we did, right? We found out that -5 was an answer. But now let's go ahead and find the other guy, right? We found it was 3/2 or 1.5. So we go second calc. We choose the 0 button. Okay, now, let's go. We're still, look at that. X is still in the negatives. X is still in the negatives. Here it goes. There it goes. So I go to about where it is. Left bound means I go to the left 2 times. Enter. I go to the right 2 times. And hit enter, and the 0 is going to be in between those guys. I hit enter. I bet you it's 1.5. Booyah, booyah. Okay, and that's how we do it via the calculators. Okay, and that's not too bad. If I went fast on that guy, you know what your job is to do? Is to try to do this one right here. Okay, do the same thing we just did. Go back and just watch my watch how I did it. Okay, and make sure you can get that done. All right, we'll practice some more of that in class. But you guys need to be practicing it at home, okay? More practice right there. Are we done, Zoe? Oh, no, we have a word problem. So I'm going to kind of do the same thing in this word problem right here, okay? But we have a function, this bad boy right here. Ooh, I'm kicking a soccer ball. The cocoa ball, spling. All right, and it says the height is y and the distance that you kick it is in x, which is meters. How far does the soccer ball travel? How far? Woo! It's a parabola probably, right? If I go, okay, how far does it go? Oh, and how high does it go? Okay. And it says to describe a possible domain and range for this. Okay. Well, hopefully you know the domain. The domain is the x's is how far this guy could go, which would be from like 0 meters all the way to like what, maybe 100 meters or something like that. Could go on forever. And same thing with the height. The height would probably start at 0, right? Because it starts on the ground. And then it goes, can you kick a ball up forever? No. So you pick something of what you think as high as that could go. But this is strictly a calculator problem, class, which is kind of nice. All right, I'm going to show you how we do this in the calculator. Hopefully, like I said, I asked you to do to practice that last problem. Hopefully you did, because it's going to get you more familiar, but we're going to do it again right now. So it's negative 0.03x squared. Okay, so let's go negative 0.03x squared. Okay, and then what else do I have? Plus 1.6x. Plus 1.60x. All right, and then we're going to zoom 6 that bad boy. I might have to extend this. It's a real life problem. Let's see what it's looking like. Oh, so it starts at 0, 0. That makes sense. Oh, dude, this boy can kick. All right, so I'm going to have to go much higher. Okay, so when we do our window, our domain is really the x's. So let's go from 0. Ooh, but I'm going to go from -5. Why go from -5? You'll find out in a moment. It looked like he kicked that ball far. So let's go to 50 meters. I'm going to put a 0 for my scale. Remember, that's always helpful. Ooh, okay, and I'm going to go -5 for the y. You're going to find out why I'm doing that in a moment. And how high? Let's go to 50 on that bad boy. Okay, now you can look down here on my screen that still is not going to fit it, because this is like the man of men soccer players. This dude kicks this ball far. Maybe not so high, but really, really far. So let's go back to window. Man, I'm going to have to go to hundo. I'm going to go to 100 just to be safe. I don't want to keep on doing this over and over again. I should have changed my scale so I didn't have all those little tick marks. And then I go booyah. There's the soccer ball. Okay, this guy's got some skills. Now, how far did it go? Well, it went as far as when it got back to 0 or the ground. So it starts at 0, 0, and it goes to 0, right? So then I'm going to hit second. Then this is why I had to have the negatives, because I'm going to find the 0. Okay, and I'm going to go, see, there it is. And the only way I can find the 0 is I got to pick something to the left 2 times, remember? And I got to pick something to the right 2 times, which means I'm going to go below. So that's why I needed to pick some negatives, okay, even though negatives we know is not a possibility. It's not going under the ground. What you talking? So make sure you write in a sentence that this soccer dude, the man, okay, kicked it 53.333, and we always round to 3 decimal places, 53.333 meters. Well, another question was asked was how high did this dude kick it? So we go second calc. It has a maximum. Remember, we did this back in our first unit, our first part of this quadratic chapter. And then we go to where we think it is. And then we go 2 times to the left. And we go 2 times to the right. And you just got to make sure those little lines that the maximum is in between there. And then there it is, 21.3. So he kicks it as high as 21.3. Okay, and guess how far it has traveled? 26.666 meters. Okay, and that's how we answer those. Make sure you answer those as sentences. Okay, and I'm not going to write it out, but hopefully you did a good job of taking notes and writing down answers as we did that problem. We just have one last page to go, and some of these problems can be a little bit tougher. So I'm going to look at a couple of them. We're going to look at 42 and we're going to look at 48. Okay, here we go, 42, because it looks like it's got a lot of craziness involved with it. Okay, now here's the first thing when you're dealing with a quadratic equation. All right, for one, we always kind of want our x squared guy to be positive. Just makes it easier. So if you notice, I'm going to have to move a lot of stuff here because I need to get a 0 on one side. All right, but I want my x squared to be positive. So since x squared is on the left side, I'm going to move everything to the left side. And there's technically no rule. Like, look at that guy right there. Maybe I should move everything to the right-hand side. And you can. It's the beauty of math. All right, as long as there's no magic, you're good to go. All right, so let's move this stuff. I'm going to move this 6x, this 6 over here, and I'm going to move this 6x over here. And I can do it at the same time. Okay, x squared, nothing to combine with that. 2x and a 6x becomes a 8x. And then there's nothing that you can combine the minus 6 with, so we go there. Booyah. Okay, now what's interesting about this problem is now super duper fast. It looks like it's awesome. So I'm going to do a little side work. 1 times negative 6 is negative 6. 8 is 8. Nothing works. Well, what do I do if nothing works? Well, then that means it's going to be a calculator's problem. All right. And that means you just have to graph it and find out where it crosses the x-axis. You know what? And I feel like it's kind of important. So we're going to do one more of those guys together. Okay. Plus 8x minus 6. So let's go again here. Plus 8x minus 6. All right. So we're going to go x squared. Gosh dang it, I said it about 3 or 4 times. Plus 8x minus 6. Okay, and we're going to go zoom 6 because I want to know where, oh, there it goes, crosses and crosses. So then remember, I'm just going to find one of these guys, okay? We go second calc, we choose 0. And guess what? Since I was not able to do that like cross method, the SAT would have to let you use a calculator, which means this is going to be a decimal answer. Left 2 times, right 2 times, and it's going to give me an answer. See, x equals 0.690. All right, and then the other one will give you a decimal too. All right, but I'm not going to go ahead and waste your time doing that. You guys are more than capable. Now, there's one other guy that looks a little bit different here, and it would be 48. So let's go ahead and take a quick look at 48. Okay, why does 48 look different? Well, what the heck do I do here? Well, you got to simplify first. Okay, that's x plus 3 times x plus 3. Oh, that's FOIL method. That'd be x squared plus 3x plus 3x plus 9, which would be x squared plus 6x plus 9. So this little left-handed piece is x squared plus 6x plus 9 still equals 9. Well, I need to turn this into a quadratic. How do I do that? Minus 9 minus 9. Spling, spling. Ooh, x squared plus 6x equals 0. And guess what? There are not 3 things. So that means I don't go over to the side and I don't do the little x thing. I go ahead and do what we did in section 4.4, which is there's a common factor between these two guys. What's common? An x. And if you take an x out, which is division, you'd be left with an x and a plus 6, and it still equals 0. And believe it or not, you have two factors. This here is so simple, we don't put parentheses, but you could. So that means x equals 0, or, right, x plus 6 equals 0. Okay? And that guy's done already. This guy here, you got to subtract the 6, and that's done. That's it. Okay, and that means if you put a 0 in for the x's, you get 0 as an answer. If you put a 0 in there, you get 9 as an answer. If you plug a -6 in here, you're going to get 0 as an answer. If you plug a -6 in here, you're going to get 9 as an answer. If you don't believe me, do it. Okay? So we want to be very efficient at not only being able to do these by hand, but also being able to use our calculators. Make sure you guys come in for help if you need it. Okay? Hopefully that was good to go. Aloha. See you next time.